Okay, let's hope for fewer networking issues today, although it's still warning me that the network's unstable, which is really getting irritating. Let's see just how bad it is. Going to do senior round 1, just check the SAMO website, and apparently round 1 is tomorrow, which I did not realize. Then after that I guess we can do round 2 papers or something else entirely. Why is this? I don't get it. Okay, well, there's nothing I can do about the internet, so let's get started. Looks like in 2016 they don't even have a cover page in the PDF, and 2016 is sort of no, still quite a while after I was out of high school already. Although the arithmetic problems stopped being of the kind that you can quickly do in your head by the looks of it. Although still not that bad. Okay. So here what we have is the numerator simplifies to 16 times 2016 over 1008, and 2016 over 1008 is 2, so this becomes 32, which is option C. Okay, let's look at question 2. People outside are quite loud. Okay, question 2 asks us, which term must be removed from the sequence a half, a quarter, a sixth, a tenth, a twelfth, so that the sum of the remaining terms is equal to 1. I feel like we've done this paper before. Have we? Yeah, I feel I definitely... This feels very familiar. Interesting. Yeah, definitely. This pen question are both okay. I think we've done this before. I don't know when. I don't want to... When would that have been? Okay, it wasn't the first time, so... I'm just quickly looking through the notes from some of the old streams to see if I can see this, because like I said, this feels very familiar. Okay. Wasn't that one? Was it that? Wasn't that one? No, actually I can't find notes on it. Should I carry on with this one? Um, yeah, we can, I don't know what sort of, where's the best place to find similar to SAMO without being SAMO, but I don't know, like which UCT maths contest, maybe. I'll see if there's past problems for that. Yeah, I think I'm going to go see if 2015 looks less familiar. This does look a little bit less familiar. Maybe all the questions just look the same after a while. Maybe they're all just, yeah, basically the same question asked year after year after year after year. Okay, I'm gonna do 2015. Let's edit the stream title to say 2015. Let's add a link to the 2015 paper in the description. Okay, copy that. Let's alright. Is that gonna work? Okay, that's fine. And I don't know if there's a point in adding it to the Discord as well, because as I explained, it's very easy to figure out what the URLs are for the papers. But I will anyway. This one is SAMO 2015. Cool. First question is literally exactly the same style, just with different numbers. Well, no, not quite. In the 2016 version, they had both of these numbers being 2016, whereas in this case they have one of them already being 2 times 2015. So in this case this is slightly harder than the 2016 version. This is 2015 times 2 is 4030, plus another 4 times 4030 over 4030, which is then 5 times 4030 over 4030, which is equal to 5. Okay, question 2 asks us the largest number below. So you don't have to work them out very carefully, because it already looks like the 4 squared is likely to be the largest, because all of the others is about 7, 8, 9. So this one's exactly 8. This one is 7.5, which is about 7 or 8. This one's exactly 9. This one's 8-ish. Whereas this one is way larger. Okay. Question 3 says the sum of 3 different positive integers is 7. So one of the things I watch way too much of on YouTube is this guy who solves Sudoku puzzles, and as a result I know straight away that the 3 numbers that add up to 7 are 1, 2 and 4. But you could do it by trial and error. If the smallest number you include is 2, then the smallest is 2 plus 3 plus 4, which is 9, which means that one of the 3 numbers must be a 1. And then once you have a 1, you want two numbers that add up to 6, and so they have to be, well, they can't be 1 plus something because you've already used the 1, and so it must be 2 plus 4 because you can't use 3 plus 3. If you wanted to go through all the painful, rigorous detail, that is, but I mean, it's not hard to see that 7 is 1 plus 2 plus 4. So the product is 1 times 2 times 4, which is 8. I've got a feeling there might be lag again today, but again, not much I can do. Hopefully it won't be 20 minutes worth. Hopefully it will just be a couple of minutes that we're out by. Okay, question 4 asks us, if 4,350 is written as a product of its prime factors, and the largest prime factor is what? So we already saw that this was 2 times, oh no we didn't, it was 4,030 that was in the first question. But this is 2 times 5 times 435. And then we want to break this apart even further, so this is a multiple of 5. This number is also a multiple of 3, but the 5s are the most obvious factor. Times 87. Now that is 2 times 5 times 5 times 3 times 29. And 29 is a prime. So hope I haven't made any arithmetic mistakes. Okay, question 5 is a slightly disguised system of 2 equations and 2 variables, but only slightly. So this difference of squares over here tells us that x minus y, x plus y is equal to 21. And we also know that 2 times x plus y equals 14. And so x plus y is 7, which we can then substitute back into the previous equation to get x minus y times 7 equals 21, and that gives us that x minus y equals 3. Okay. If x is the cube root of 900, then which of these are true? Cube root of 900 is, I don't know, it's just below 10, because 1,000 is 10 cubed, that is. So the question is it also smaller than 9 or is it bigger than 9? So cube root of 900 is somewhere around 10. And so we do know that it's smaller than 10. So now the question is just, is it bigger or smaller than 9 cubed? If it's bigger than 9 cubed, then we know that B is the answer. But we should check. But 9 cubed is 729, so it is bigger is the answer. So it is between 9 and 10. But this is the question that you'd be asking yourself while solving the question. Or bigger or smaller than 9, I guess, is the appropriate question for the cube root. So we know that 9 cubed equals 9 times 81, which is 729. And so we know that 729 is smaller than 900, which is smaller than 1,000. By taking cube roots, we get that 9 is smaller than the cube root of 900, is smaller than 1,000, is smaller than 10. And that is option B. Okay, question 7. Question 7 asks us, if 8 athletes run a race and no 2 athletes finish exactly together, the number of different possible results for the first, second and third position is what? So there are 8 options for the first position. Because it could be any of the 8 athletes. There are 7 options for the second position, because it can be any of the 8 athletes except for the one that happened to be first. And then there are 6 for each of these 56 possibilities for first and second. There are 6 options for the person placed first, third. And so we get 8 times 7 times 6, which is 336, I think. 56 times, not times 8, times 6. 50 times 6 is 300, 6 times 6 is 36, so this is 336 options overall. Question 8 asks us, let's copy it first and then see what it asks us. So question 8 says, the values of x satisfying the equation x minus 7, x plus 48 are what? Well, this is a case where we can, because it's multiple choice, you can plug in the values and see if you get the right result. The alternative is to actually multiply this out and solve the quadratic, but in this case we can eliminate this one, because when you plug in 7 you get 0, not minus 48. We can eliminate any of them that include minus 12 for the same reason, because if you plug in minus 12 you get 0. Minus 7 would give us, and 12 would give us minus 14 times 5, which is minus 70, which is not minus 48. 4 minus 7 is negative 3. Negative 3 times 16 is 48, so 4 is correct. And then negative 9 is also correct, because negative 9 minus 7 is minus 16. Negative 9 plus 12 is 3. Negative 16 times 3 is negative 48. So by trial and error, this is the correct solution. And you can do this if it's a multiple choice question. You know exactly one of the options is correct, ideally, if someone competent set the paper. And so just try all of them. But if you wanted to, you could multiply that out and you'd get x squared plus 5x minus 84 equals minus 48. So you get x squared plus 5x minus 48 plus minus 84 plus 48 is 36, negative 36. And so you'd want two numbers that add to 5 and multiply to negative 36. Again, you could actually solve this. You could find those numbers yourself and see that they are 4 and negative 9. Negative 4 and 9, my bad. Or you can again just trial and error through the options that they already gave you. But this is the same thing as x minus 4, x plus 9 equals 0, and so x is 4, x is negative 9. Or I suppose you could use the formula. If you really did not want to do it this way, you could say it's negative 5 plus or minus the square root of 5 squared plus 4 times 36 over 2. That's, yeah, just don't. I mean, we already know the answers are going to be 4 and negative 9, but yeah, this seems like the least efficient way. Well, that's also strictly not true. Least efficient way anybody's likely to actually try. Because you could just, try all infinitely many possibilities one by one. You can't if you don't know that the solutions are natural numbers actually, because you can't, there's no way of going through all the real numbers one by one. Or there is a way, yeah, whatever. I'm talking too much about this question for one where you can just try all the possibilities. Okay. Each interior angle of a regular 180-sided polygon is equal to what? Well, we know that the sum of all of the interior angles of an n-gon is n minus 2 times 180 degrees. And in the past we've spoken about a couple of ways that you can justify this, but one of them is by breaking the n-gon up into n minus 2 triangles. Yeah, and then each triangle, the interior angles add up to 180 degrees. So for a 180 gon, the interior angles sum to 178 times 180 degrees. And so if it's regular, in other words all of the angles are equal, each angle is 1/180th of this. And that is 178 degrees. Which is option E. Okay. This also feels like a question where we've done something similar. The list of numbers 16, 19, 24, 25, 30, 31, 32 and 46 is the same median and mean. Oh, they say x is bigger than 46, so we don't actually even have to try the cases for x potentially being the median. In this case we know x is not the median. So there's how many numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is the fifth, and they've sorted them for us, aren't they nice? So the median is the fifth number when they're in sorted order. In this case, because there's 9 numbers. So it's 9 plus 1 over 2. To keep it general. And in this case they are pre-sorted. So we can just say it's the 1, 2, 3, 4, 5th number is 30. The mean, on the other hand, is the total of all of the numbers divided by how many numbers there are. So that's going to be 16 plus 19 plus 24 plus 25 plus 30 plus 31 plus 32 plus 46 plus x all over 9. And now we need to add these things together. The 16 plus the, okay, let's write this out. 16 plus 19 plus 24 plus 25 plus 30 plus 31 plus 32 plus 46 plus x, I guess. So my strategy is to combine things that are going to make it easier to combine them with other numbers and get them up to nice multiples of 10 or multiples of 5, because they're easier to work with in a sense. So these two add up to 35, and the 35 together with the 25 gives us 60. On the other hand, the 24 with the 46 gives us 70. And so this is the 70 plus the 30 is going to give us 100, but that's fine. So this list becomes 60 plus 30 plus 31 plus 32 plus 70 plus x. The 30, 60 and 70 is going to be 160 plus 63 plus x, which is 223 plus x. Yeah, I see there is lag again. That's sad. Okay, so we need 223 plus x over 9 to be equal to 30. So 223 plus x is going to be 270, and that gives us that x is equal to 47. Amazing. When they said it's bigger than 46, they weren't lying. It's just not a lot bigger than 46. Okay. Lewis Hamilton, who is indeed still a Formula 1 driver, I think. My brother doesn't like him. I don't know enough about him to have an opinion. So he completes a 72 lap race, traveling at an average speed. Is that normal for F1 cars? 288, an average speed of 288 kilometers an hour. Like on a straight line, I can believe it, but okay. Traveling at an average speed of 288 kilometers an hour. Each lap is 6 kilometers in length. The time taken in hours for him to complete the race is what? Well, he travels 72 6 kilometer segments, and then we divide that by 288. He travels 72 laps times 6 kilometers per lap equals 72 times 6 kilometers. I'm actually not even going to bother. 452, but I think it's going to be easier to realize that this 288 is also a multiple of 72. Round 3 is quite a jump up from round 1, but sure, I could do that. You're gonna hear me say that in a couple of minutes, I guess. I do. So yeah, I think it's going to be easier to realize that the 288 is 4 times 72, and then the 72s are going to cancel, so that's why I'm leaving it as 72 times something. So the time taken is the distance divided by the speed. And in this case we know that 72 times 6 kilometers divided by 288 kilometers per hour. Like I said, it's going to, you can cancel this down by realizing that 288 is 4 times 72, and so this is 6 over 4 hours, which is 1 hour 30 minutes. Yes, which is option E. 57 was the answer to, it's different to the answer I got for the previous question. I hope I didn't add up wrong. It's great that you're all saying stuff in chat. It's just a little weird with the lag. The fifth number is I'm now doubting myself, so let's double check this question. 1, 2, 3, 4, 5. Fifth number says 9. There are definitely 9 numbers. Fifth one is definitely 30, so we do want the mean to be 30. Numbers are 16, 19, 24, 25, 30, 31, 32, 46, and x. Over 9 is going to be 30. 19, 24, 25, 30, 31, 32, 46, and x. Those are still 35, those still become 60, those do become 70, so this is 60 plus 30 plus 31 plus 32 plus 70 plus x, which is still 160 plus 63 plus x, which is still 223 plus x, has to be 270, so yeah, I still get 47. Get 57, that means I'd be missing a 90 somewhere, like, or that the addition is out by 90, which I don't think is the case, but it's conceivable. I get 47. Okay. Moving on, let's look at question 12. I'll paste it on this page, but I think I might need a whole page to... there's space to redraw the diagram. If D, E, and F are the midpoints of AB, CD, and AE respectively, and the area of triangle ABC is 24. Oh, I see. So that's what kind of question this is. So the point is that if you have a triangle and it has area A, then if you have the midpoint of any of the sides, each of the two triangles that it divides the large triangle into has area A over 2. And the reason for this is that the height of the triangle hasn't changed, but the base is now half of what it was. So this is half of the base. This is half of the base. But each small triangle has the height is height doesn't change. So in this case, that means that triangle ACD is going to have area 12. And that means that triangle AED now has area 6. And that means that I don't think there's a good color. Let's use red. That means that area triangle DEF has got half of that again, which then has got area 3. Okay. this case, so question 13 asks us the last digit of 2 to the 2015 plus 5 to the 2015 is what? And the important thing about the last digit of powers is that they always go in cycles. If you look at the 2, the powers of 2 go 2, 4, 8, 16, which ends in a 6. Then 32, which ends in a 2 again, 64, 128, 256. And then 512, 1024, and so on. So the last digits are 2486, 2486, 2486, 2486, 2486. And so on. And this is a completely general phenomenon. Last digits always start repeating. And that's because you can't keep getting a new last digit forever, because there are only 10 possible last digits. So at some point you have to repeat them, because after 10 terms or 11 terms, you've got 11 last digits, but only 10 possibilities what they are. So 2 of them must be the same. Because you can't. It's an example of something called the pigeonhole principle, or in French it's le principe du tiroir. And once one of the last digits repeats, so the first time you get one that's duplicated, the sequence just is identical after that, because each last digit only depends on what the previous one is, because you're doubling the last digit every time. So once we get to 2, after a 2 we're always going to have a 4, and after a 4 we're always going to have an 8, and after an 8 we're always going to have a 6, and after a 6 we're always going to have a 2. And so you can see that this is going to cycle, because we have to eventually see a digit we already have seen before, and after that the sequence just repeats whatever came after that digit the first time we saw it. So in this case we know that they repeat in blocks of 4. So then the question is, how many complete blocks of 4 do we have if the exponent is 2015? And where are we in the next block of 4? Well, one of us got 270 minus 227 wrong. It's believable that it could have been me, but when the exponent is 2015, so 2016 is a multiple of 4, so we're actually going to be, I think we're going to be in like the third, I think it's going to end up being an 8. We have gone through 503 complete blocks of 4. Which would cover the first 2012 powers of 2, and so then we are on the third number in the next block of 4. So we would have gone 2013, 2014, 2015. And so that implies that 2 to the 2015 ends in an 8. Or an 8, I guess. 8 starts with a vowel. As for the power of 5, powers of 5 always just end in a 5. So 5 to any power. It still cycles, it's just that the cycle length is 1. And so the last digit of the sum of these things is the same as the last digit of 8 plus 5. So it's a 3. And that is this option over here. Here they were mean with the, well, not mean, they were sensible with the options for the multiple choice. Because if you think about it, you're going to see that this obviously has to be an odd number, and they gave us every odd number as an option. So actually, they're all conceivably correct, I guess. Let's try the next question. Yeah. The sum of the squares of 3 consecutive positive integers is 770. The largest of these integers is what? I don't see a easy way to do this other than to just do the algebra. So let's say let the numbers be n minus 1, n, and n plus 1 as the 3 consecutive integers. And I'm picking that because we're going to get at least a little bit of cancellation if we use n minus 1 and n plus 1. It's supposed to be 770, and so this is n squared minus 2n plus 1 plus n squared plus n squared plus 2n plus 1 equals 770. And that's why I wanted the minus and plus 1, is so that this minus 2n cancels with this plus 2n. Because I mean, you could have made it n plus 1 and n plus 2, but then you're going to have n squared plus something, n plus something. And I think this is just going to be an easier equation to solve. So this is 3n squared plus 2 equals 770. Subtract 2, hope that the resulting number is divisible by 3. 768 is divisible by 3. And let's hope that 768 over 3 is a square. So 3 goes into 7 twice, into 16 5 times, that's 256, which is 16 squared. And they were mean enough to include 16 as an option, because we want the largest number, which is n plus 1. So 17 would be that. Oh, but this is this is again multiple choice. So you could have tried these one by one. So if the largest number is 15, then the question is well, 15 squared plus 14 squared plus 13 squared, you could work that out. 16 squared plus 15 squared plus 14 squared, you could work that out and see it's not 770. 17 squared plus 16 squared plus 15 squared, you could work that out and see that it is 770. So I guess this is actually also a question where you could use that technique, if we want to call it a technique. Okay, a die has 20 identical equilateral triangular faces, which is in fact one of the Platonic solids. It's an icosahedron, numbered from 1 to 20. If 2 such dice are rolled, the most probable sum of the numbers showing up on the top faces is probably going to be 21? Yeah, I think so. So, for the point is that for k smaller than yeah, I don't know, it's a bit hard to justify, but it's intuitively true. So let's say for k smaller than 21, the number of ways to write k as a sum of two numbers on the dice, so the number of possible rolls, is k plus 1, I think. Rolls, no, it's k minus 1. Because it could be 1 plus k minus 1, or it could be 2 plus k minus 2, or it could be 3 plus k minus 3, or the first die could be anything up to k minus 1. And so there's k minus 1 possibilities over here. And this works if k is at most 21, because we want the second number to be at most 20. And the first number as well to be at most 20. And here the k minus 1 is at most 20. So at least amongst the numbers smaller than 20 or at most 21, 21 has got the largest number of possibilities. And so the question is just to justify that for k larger than 21, you can't do better. So for 21 being smaller than k being less than or equal to 40, the number of possible rolls is what? I don't know what it is, but the point is that you can't ever use the 1, so it's definitely going to be smaller than 20. Because it means that this first number in your pair has to be 2, 3, can only come from the numbers 2 up to 20, so there's at most 19. Because we can't use a 1. And for numbers larger than 40, you can't roll that number. The largest possible number you can roll is 40. Okay, and for k greater than 40, it is impossible to roll k. It's also, I mean, I could have just rolled it into this previous argument, because impossible is still at most 19 ways to do it. And it's still true that you get at most 19 because you can't use the 1 if the total you want is bigger than 40. So this is a little bit redundant, but it doesn't matter. And so you see the number that has got the most possibilities is 21, because there's 20 ways to roll a 21. Could be 1 in 20, 2 in 19, 3 in 18, and so on, down to 1 in 20 and 1. And this is similar to how on a d6 the most common total is 7, which is why it's annoying that the 7 in Settlers of Catan, for example, is the rubber, because it's the most annoying thing to roll, but it's also the one that statistically is the most likely. Although Catan defies statistics, because 6 and 8 are supposed to be the next most common, but everyone knows that 2 comes up the most, even though it's the least common. It reminds me of a scene out of one of the Discord novels, I just can't remember which one. There's a dragon attacking the city, and the way that they defeat the dragon was by using the well-known fact of mathematical statistics and physics, that if the probability of something is exactly 1 in a million, then it's guaranteed to happen. And so they sat around trying to make their attack on the dragon more and more bizarre, so that the odds go down until they reach exactly 1 in a million. So how about if I shoot the arrow and it bounces off the bucket and then flies through that window and then hits the dragon, then what are the odds? Question 16 asks us, on a line segment with the points RA, T, and E, the ratio RA to AT is 1 to 3, and AT to T is, let's draw this line segment, that is going to be the easiest. So I could have just drawn the line first and then put in the points, I guess. RATE. Ratio of RA to AT is 1 to 3. So this is a x and a 3x. And the ratio of AT to TE is 5 to 2. So this is 3x over 5 times 2. Yeah. Because 5 of these must be 2 of these. Cool. And then the rate RA to TE is the same ratio, I think that's the symbol for same ratio, as x to 6x over 5, which is the same ratio as 5 to 6. Which is option D. Copy. Question 17 asks us the number of squares that have -1, -1 as a vertex, and at least one of the coordinate axes as a axis of symmetry is what? So let's see. We want this point to be on the square, and we can pick either the x or the y axis to be an axis of symmetry. So let's look at what happens if we have the y axis, in which case the only requirement is, so this is one of the vertices actually. So if the y-axis is an axis of symmetry, this means that this point on the other side of the y-axis must be another vertex. This is also a vertex. And so I suppose they are now hi. Hi. So there are now two possible squares, because these are two of the vertices, but they could be the bottom two vertices or the top two vertices. So our square could go, it's not the color I wanted. Our square could be this one, or our square could be this one. And I'm not going to say therefore there are 4 squares in total, because that's actually not true. So the thing is that this square over here that we get also has the x-axis as an axis of symmetry, so we're going to count it once as 1 for the y-axis and once as 1 for the x-axis, and so we end up double counting it if we say that there are 4 squares. So this is -1, 1 and 1, 1. But let's just draw these out. So that's what happens if the y-axis is an axis of symmetry. So 4 is probably the most common incorrect answer and is one of the options. Yay. Because the other possibility is that the x-axis is an axis of symmetry, which forces this point to be one of the vertices. So this is one of the possible squares, and no. This is a square that we've already seen. And so actually if you draw all of the possibilities, you end up with this diagram. You can have this square not drawn to scale, or this square, or or this square. And there are only actually 3 possible squares over here. Okay. I'm a bit confused since I wanted to try find where the last digit got to 0 for question 14. But 17 squared ends in a 9, 16 squared ends in a 4, and 15 squared ends in a 5. 9 plus 4 plus 5 is 18. That is a valid concern. So let's see, I got to the answer is 17 is the largest, so we want to be adding 15, yeah, the problem is that 16 squared ends in a 6, but your thinking is very valid. The idea is a very good one, but 16 squared ends in 6. And that is then going to end in, when you add them, they do end in a 0. Yeah. Okay, question 18. In how many different ways can you get from point A to point B if you can only move up or to the right? So there's 2 ways. One is sort of from scratch. So we have this 4x2 grid. And the one thing we can do is for each point on the grid, we can record how many ways are there to get to that point. So there's 1 way to get to the starting point. To get to this point over here, we had to have come from the left, because we can never move down, we can only move up or right. So there's 1 way to get here. Similarly for this point there's 1 way, for this point there's 1 way, for this point there's 1 way, because for all of them we had to get here, for example, we had to take the one path that gets there and then add a right step. And to get here we had to take the one path that gets here and then add a right step. For the next row it's a little bit more complicated. There's still only 1 way to get here because we had to take a step upwards. But to get here is where it gets interesting, because here we could have come from the left and there's one path that gets us here and then a right step, or we can come from below. So there's one path that gets us here and then we add an up step, and both of those are a path to this point. So we had to come from either there or there. There's 1 way to get here, and for each of those ways we add a right step, or there's 1 way to get below this point, and for each of those we add an up step. Similarly for this point, we had to have come from the left or from the bottom. If we came from the left, there's 2 possible paths that gets us to the point to the left, and for each of those 2 paths we add a right step, and so that there's 2 ways to come from the left and there's 1 way to come from below, which gives us 3 ways in total. For this point, again, we had to come from the left or the bottom. There's 3 ways to come from the left because there's 3 paths that get us to the point to the left. And for each of those paths, we add on a right step at the end of the path. And for any path that gets to the point below this, we add on an up step. So there's 3 plus 1 is 4 ways. And then the same logic tells us that there's 5 ways to get to this point. In this point up here, there's 1 way to get to it. For this one, the same logic tells us there's 1 way to get to the left of it, 2 ways to get below it. And then we add either a right step or an up step, gives us 3 paths. For this one, there's 6 paths, the 3 plus 3. For this one, there's 10 paths, which is 6 plus 4. And so for this one, there's 15 different paths. The other way to do this quickly is we take 6 steps in total. 4 of them are to the right and 2 of them are upwards. Alternatively, there are 6 steps in total, and we must choose which 2 of those are going upwards. Upward. So for example, if here are the slots available for our instructions, and our instructions are going to look like go right, go up, go right, go right, go up, go right, for example. Or our instructions could have been go up, go up, go right, go right, go right, go right. So each possible path is going to correspond to a set of instructions of length 6, where 2 of them is go up. And so the number of such sets of instructions is just the number of ways to pick 2 objects out of 6. We want to pick 2 slots out of the 6 and say that those 2 slots are going to be the go upwards instruction. And so this can be done in 6 choose 2 ways. And 6 choose 2 is 6 times 5 divided by 2, which is also 15. Okay. Question 19. ABCD is a rhombus. E is the midpoint of BC. If BAE is equal to X, then FECG is a kite. I'm going to have to be reminded what a kite is. A kite just means 2 sets of... A kite is this thing, right? Where you've got 2 sets of sides that are equal to each other, and the diagonals are perpendicular to each other. Well, it turns out that in this case the diagonals are, if you have those sides equal, then diagonals are guaranteed to be perpendicular. So it's not part of the definition that the diagonals are perpendicular. I think it's good enough to know that you have the 2 sets of adjacent equal sides. Suppose there's a couple of... I'm wondering if using the equal sides is going to be what's important, or if the perpendicular lines is going to be the right consideration. Well, yeah, actually, I think X is going to be 30 degrees because there's a nice equilateral triangle hiding here. So let's just question 17. Yeah, I'm 2 questions ahead. Cool. That's at least not too far behind. Is the... Okay, let's redraw this thing nicely, but then I need to zoom up so I can actually see it on the screen, and then let's mark these angles. So here's my beautifully drawn rhombus to the midpoint. And yeah, we're given that this is a midpoint. We're told that this angle is equal to x, and the question is, what is x? Okay, this is a G, F, E, and let's call this length y and this length y, and you'll see why in a minute, because we're told that this shape over here is a kite, which means that this side is also equal to y, and one of the properties of a rhombus is that the diagonals bisect each other. I can never actually remember, like, so in a rectangle they bisect each other and they're of equal length. In the rhombus they bisect each other. Don't think they're of equal length. I think if it's in a parallelogram they also bisect each other. So what was special about a rhombus is that they're also perpendicular. I think so. Doesn't matter, but I'm pretty sure that in a rhombus the diagonals bisect each other, which means that this piece over here is also a y. And the defining property of a rhombus is that all of the sides are equal, which means that this side, this side is the same length as this whole side, which is then 2y. And what that implies is that ABC is an equilateral triangle, because all of its sides are 2y. And then x is then, so we have this equilateral triangle ABC, and this median then turns out to also be a altitude and an angle bisector and everything else you want it to be. So in an equilateral triangle you have that situation, which means that this x is half of angle BAC. It's not true for any midpoint, that's only true in this case because it's an equilateral triangle. So in general the angle bisector and the median are not the same thing. So let's say here's the midpoint maybe, but the angle bisector, here it looks a bit like the angle bisector. You'll just have to believe me, they're not in general the same thing, but they are in an equilateral triangle. So in this case we do get 30 degrees. In question 20, Analyze put 120 identical cubes together to form a rectangular prism. Fortunately, there's multiple ways she could have done that. Like 2 by 2 by 30 or 2 by 3 by 20. She then painted all 6 faces of the prism. Once the paint had dried, she disassembled the cubes and found that 24 of the cubes had not been painted on any face. The surface area of the prism she formed, I take it with the 120 cubes, was what? Yes. Yeah, I think that's fine. So, the one possibility that we have to rule out is that any of the side lengths was... well, that's obviously true. Yeah. None of the side lengths is 1, because then every cube would have had paint on at least one of its faces. Which means that if the length, width and breadth are L, W and B, then the number of cubes without any paint on the faces is also a rectangular prism, but all of the sides are 2 shorter. Let's call it length, width and breadth. Then the number of unpainted cubes. Well then, okay, the first thing we know is that length, width, breadth is 120. And we also know that the number of unpainted cubes is L minus 2, W minus 2, B minus 2. Is 24. And let's just draw a picture of what. It's hard to draw this picture. Okay. But let's try anyway. Okay. And there's a prism. And actually, let's draw this inner one. Okay, that's where there's no paint, because for all the others, there's these cubes over here. Let's again not confuse the colors. These cubes over here have all got paint on this front face, whereas these cubes over here have all got paint on this face over here. And these similarly for the cubes at the top and the cubes at the bottom. That which has to line up with that blue face but doesn't in this picture. Okay, that slab of cubes have all got paint on the top face. And so you can see that the ones that don't have any paint on is this L minus 2, W minus 2, B minus 2 prism in the middle. And this is convenient actually, because if we think about what the surface area is of the original cube, not cube, parallelepiped, rectangular prism, it is 2 times LW plus LB plus WB is what we want to calculate. And this thing, when we expand it, we get that LBW minus 2 times LW plus LB plus WB plus 4 times L plus B plus W. It's going to be annoying. Minus 8 equals 24. And think it's not going to be as clean as I'd hoped. There's still going to be more to think about, but this does at least tell us how the surface area relates to the total of the 3 dimensions. But this isn't quite good enough. suppose you could trial and error after that, but I don't see a very nice approach. I suppose we have to trial and error anyway. We want... Oh. Cool. Well, let's see what we get. We know LBW was 120. 120 minus the surface area plus 4 times the sum of these lengths minus 8 is 24, and so the surface area equals 144 plus 4 times the sum of the 136. Yeah, 136 plus 4 times the sum of the dimensions of the cube. That does not easily narrow it down. The only other thing we know is that all of these things must be integers. So yeah, we want to factorize this in such a way that each of the factors we know this is at least 3, I guess. That just tells us that the answer is at least 148. And that's obviously true. Maybe we're fortunate and the answer ends up being the largest one possible. So the maximum sum is... I don't know what the closest cube to that is. 4 cubed is 65 cubes. Each one's at most 5. So sum's minimum possible sum is about 15-ish. A bit less than 15. That forces this to actually be quite large, the surface area. So it might be the case that you can prove that it's at least 156, and therefore yeah, actually I think there might be a mistake here, because the sum is definitely bigger than 12, so this is already going to be 48 plus 136 is 184. So that's not one of the options. So I've done something wrong. $120. 24. Minus 130. This seems right. Let me go to the cube root of 1, which is 4 and a bit. This is bothering me. Why this is bothering me? Because why I feel like... Oh, It's because I am dumb. I don't want to add 24 and subtract 8. I want to subtract 24 and 8. So it's not 136. It's 90 or 80 something. So it's 112 minus 24 is 108 minus 20 is 88. That makes a lot more sense. Why I was worried is that I happen to know that the length plus the breadth plus the width over 3 is greater than or equal to the cube root of length, breadth, width. It's called the AMGM inequality. And this is the cube root of 120, which is 4 point something. And so we know that the length plus the breadth plus the width is definitely bigger than 12. And when I was putting 12 in over here, I was getting something that's larger than all of the options. And that means that, yeah, we've definitely done something wrong. But this is now, I hope the 88 is correct. 112 minus 4 is 108, minus 20 is 88. Yeah, I think that's right. That does imply still 48 would give us 120, 136 actually, so that's, yeah, the secret's not going to be to get a lower bound on the surface area. We need to still do something clever. I can eliminate everything that's not a multiple of 4 at least, but that still leaves us with 148, 152 and 156. I've got a feeling we're just going to have to try trial and error. We have 2, 5, 12. Nope. Oh yeah, so none of them can be 2. None of them can be 1. So I suppose the minimum for any of these is 3. So it could be 3 times 4 times 10. 8. Doesn't work. 3 times 5 times 8. Comes 1 times 3 times 6. Doesn't work. So 4 times 5 times 6 would give us 2 times 3 times 4, which is 24. So trial and error suggests there must be a better way. There must be a better way. There's some trick I'm missing. But trial and error. Not 2, 3, 4. It was 4, 4, 5, 6. Because 4 times 5 times 6 is 120. And 4 minus 2, 5 minus 2, 6 minus 2 is 2 times 3 times 4, which is 24. And in this case, well, we could do this from scratch and say that therefore the surface area is 2 times 3 plus 2 times 4 plus 3 times 4. Or we can use this formula that we got earlier. So it's 88 plus 4 times 2 plus 3 plus 4. 2 plus 3 plus 4 is 9. That gives us 36. 88 plus 36 is 124, which is not one of the options, which is worrying. Which suggests there's still some mistake lurking here. let's try it this way. This is 2 times 6 plus 8 plus 12. It's 20. Not 2, that's the mistake. It's not 4 times 2 plus 3 plus 4. It's 4 plus 5 plus 6. Which is 88. And so this is not 2, that was also wrong. This is 4 times 5 plus 4 times 6 plus 5 times 6. I can't do maths anymore. Plus 4 times 15, which is 60, so this is 148. And hopefully this also works out to 148. 30 plus 20 is 50, plus 24 is 74, times 2 is 148. Do let me know if you find a better way to do this than trial and error. As for my trial and error, how did I go about the trial and error? So I know none of the sides can be 1, because then every cube gets painted. And the same thing for 2. If it's 2 in any dimension, then everything gets painted. So we try the smallest one being 3. So then we want 3 times, well, the other two sides are A and B, so we want 3AB to be 120, so AB is 40. And so we try 4 times 10, 5 times 8, and there are no others, and both of those don't work. And so the other option was, if the smallest one is 4, then we have to take 4, 5, 6, because the other two have to multiply to 30, and both numbers are bigger than 4. So trial and error seems to be the magic ingredient. But there must be a better way. I suppose if we I'm not going to try to find a better way. I think this is, I think trial and error is perfectly acceptable here. So yes, the 148 that's been posted in chat is in fact correct. I eventually, after many hours, I eventually get the same answer. But after bumbling about for a bit. In your head. Wow, okay. Then this the stream's going to be very entertaining then. Okay, so that's all of these questions. So what next? Someone asked for round 3 questions. Okay, so someone asked to look at our 3 questions. Any preferences for which year? I suppose I could ask my friend Python. Let's make this larger so that people can see that I'm not yeah, here we go. Okay, so from random import rand range. I can't remember if rand range includes the endpoints or not. I think rand range 2 should, or rand range 1 should always give me 0. I have definitely, that's definitely proof that it's always 0. Even though this, I mean, yeah, actually, what's the probability that this doesn't always give us 0 given this string of zeros? So it's going to be, that's a half, a quarter, an eighth, 16th, 32, 64, 128, so 256. So this is like a p-value of 1 over 2, 5, 1, 2, 3, 8. And 2 to the 8 was 256. So this is less than 0.5%, which is definitely better than the, yeah. So with p less than 0.0005, I conclude that rand range excludes the upper bound. So let's pick a random year between 2010 and 2023. 2015. Cool. This looks like we're looking at 2015, so I want senior 3, 2015. Okay. Let's do the first question and the second one, because those are the most likely to be able to be done in the like half an hour-ish that remains. Okay. Points E and F lie inside square ABCD such that the two triangles AB are, well, okay, that is a square, A, B, C, D. So the question asks, points E and F lie inside square ABCD such that the two triangles ABF and BCE are equilateral. ABF and BCE are equilateral. And this is a square, so all those lines are equal. Show that DEF is equilateral. Really? So, because friends don't let friends do geometry, the first instinct that comes to mind is to use coordinates, or something that is essentially coordinates. I think it's, I don't want to say it's clear, but it's believable that this is at least isosceles. Actually, yeah, there's an easy way to prove that, and the easy way to prove that is that we know that this angle is 60 degrees, so this angle is 30 degrees. Well, it's isosceles because all of the sides of the square are equal, and they're equal to the sides of this equilateral triangle, so this side is equal to this side, so it's obviously isosceles. I'm now just trying to work out what the angles are. So that means that that angle and this whole angle, yeah, we can work out what this angle is, in other words. Oh, that's why that's what I was doing. I was going to get that DEF is isosceles, not that CDE is. CDE is obviously isosceles, as I said. So we know that this whole angle is equal to this whole angle, which is a half of 180 degrees minus 30 degrees, which is 75 degrees. And similarly, that angle and that angle was 75 degrees. So we want to work out we know then that this whole angle, let's draw it in a different color, this whole angle is 90 degrees and this piece is 75 degrees, which means that this piece on its own is 90 degrees minus 75 degrees equals 15 degrees. And so the conclusion is that angle EDF is 75 degrees minus 15 degrees, which is 60 degrees. Okay, and then the other claim was that DE equals DF, and the reason why that is true is because if you look at triangle ADF and CDE, they are congruent because they both have a by side angle side. They both have a 30 degree side between two equal sides, and those equal sides are, yeah, so those are congruent. And because they're congruent, that means that DE equals DF. And so it's an isosceles triangle where the third angle, the not equal angle, is 60 degrees, which means that the other two angles are also 60 degrees. So let's write this out in detail. So what are the important things to notice? So point 1, we show that DE equals DF. And to get there, we note that let's say AD equals CD because of the square. It's a great reason to give because of the square. And we know that CE is equal to BC because of the equilateral triangle, which is equal to AB, which is equal to AF. So triangle equals AB because of the square equals AF because of the other equilateral triangle. Cool. And then we have that angle DAF is DAB minus FAB. DAB minus FAB. Which is 90 degrees because of the square, minus 60 degrees because of the equilateral triangle. And similarly, angle ECD, not EC9, ECD, is 90 degrees minus 60 degrees, which is 30 degrees. And so that tells us that triangle DAF is congruent to triangle DCE. By side angle side. And so DE equals DF. But the other way to sort of convince yourself that DE equals DF is that this whole figure is symmetric around the line BD, including then the lines DE and DF. And then we justified somehow that angle EDF is 60 degrees. So we know that angle ADF, because of the ADF because of the isosceles triangle. So we show, this is our goal, we will show that angle, EDF is 60 degrees. I'm busy doing one. I'll Okay, and how did we do that? We showed that angle ADF is 75 degrees. Because it's half of 180 degrees minus the 30 degrees. And so that implies that angle FDC is 90 degrees minus 75 degrees. Equals 15 degrees, and we also know that angle EDC is 75 degrees. So angle EDF is 75 degrees minus 15 degrees, which is 60 degrees. And those two facts together implies, putting these together, we get that that is equilateral. Wedge triangle EDF. Okay, there's probably time to do question 2 as well. That does not look pleasant. Okay, determine all pairs of real numbers. I hope that I hope nothing gets cut out of the stream because of the lag. That would be very annoying. Although yesterday the end of the stream got cut off once I ended the stream. Which, yeah. So maybe today I must just leave this for 15 minutes of the stream running even though I'm not streaming so that it can I don't know. I really don't know what the best course of action is. Maybe suing the internet service provider. Although I don't actually know who the internet service provider is, it's just the Wi-Fi in the flat that I'm renting. Maybe I'll I don't know. I'll see if I can make a plan. Determine all pairs of real numbers, a and x, that satisfy the simultaneous equations 5x cubed plus ax squared plus 8 is 0 and 5x cubed plus 8x squared plus a equals 0. My first instinct is let's subtract these. So we get a minus 8x squared plus 8 minus a equals 0. So this is equivalent to, but not the two original equations. The two original equations contain extra information compared to this one. A minus 8x squared minus 1 equals 0. So there's two possibilities here. So, or three, I guess. Let's say 3 cases. And let's deal with each of them. So in the first case we have that a is equal to 8. And in that case our equation becomes, or our system of equations become 5x cubed plus 8x, both of them become 5x cubed plus 8x squared plus 8 equals 0. Don't know if this has a nice solution. If it does, minus 2 seems to be a solution. Yeah, because minus 2 gives us 5 times minus 8, which is minus 40. 8 times 4 is 32, plus another 8 is 40, so it's minus 40 plus 40 is 0. So this is x plus 2. 5x squared gives us then 10x squared, so we want minus 2x. That gives us minus 4x, so we want plus 4 equals 0. Is x is minus 2 also a solution of this? That would be great. No, it's not. I think this one we're going to have to use the formula. So we get that. Or maybe actually, I should even check if this has real roots. So what is the discriminant? It's minus 2 squared minus 4 times 5 times 4. And you don't even have to work that out to know that it's less than 0, so this has no real roots. Yeah, is that true? 4 minus quite a lot, 4 minus 80. Yeah, and they want all pairs of real numbers a and x, and so that's why we can discard the complex roots there. So implies if a equals 8, then x equals minus 2 is the only real root. And it is a root of both equations. Okay, so that's one possibility, is 8 and negative 2. So let's deal with the next case. If x equals 1, in the two equations, the first one, well, they both become the same, because this condition that subtracting the two equations and getting 0 implies that, yeah, it implies that this equals this for these values of a or x. So really we're only expecting one equation. We're expecting the same equation, and we do. We get 5 plus a plus 8 if in each case equals 0. So both equations become 5 plus a plus 8 equals 0, and then that tells us that a is equal to negative 13. And then finally, x equals negative 1. When we plug it in, both equations become minus 5 plus a plus 8 equals 0. Wanted the black pen. And so a is equal to negative 3. So the solutions are a and x have to come from, one of them was a is 8, in which case x was negative 2. And the x equals negative 1 case, we had a is negative 3. And in the x equals 1 case, we had a equals negative 13. Then it's only really like 5 more minutes left, but maybe that's enough time to at least read the last question. Not the last question, the third question. So let's copy this. Okay, we call a divisor d of a positive integer n special if d plus 1 is also a divisor of n. Prove that at most half the positive divisors of a positive integer can be special. Determine all positive integers for which exactly half the positive divisors are special. I don't know how long ago I actually started around 3, so I don't know exactly how long this lag is. Not ideal. What I could do is later open the stream in myself and see, I don't know, I'll figure it out. So the intuition here for me is that if you look at the divisors, they sort of clumped together for the small divisors and then very spread apart for the large divisors. So I think the divisors larger than the square root of n are probably going to, let's take a look at a fairly composite number as an example. Let's look at the divisors of 30. The divisors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. So these divisors over here are close together. And these divisors over here are spread apart. And so we want to show something like if d divides n and d is greater than square root n, then d plus 1 does not divide n, is our conjecture. Is that once you get past this halfway point, that the divisors are at least 2 apart. In fact, probably a lot more than 2 apart. And yes, that is the easiest way to prove that, is if d divides n and d plus 1 divides n, then because d and d plus 1 are relatively prime, that implies that d plus 1 divides n. Divides n because, and this is essential, this is not always true in general, because this, we do have to justify this, the GCD of d and d plus 1 is 1. So it's not true in general that if a plus b divides a and divides n and b divides n, then ab does. Because, for example, 2 divides 4 and 4 divides 4, but 2 times 4 does not. So in this case, it's because the least common multiple of d and d plus 1 is d times d plus 1. And this tells us that d plus 1 is less than or equal to n. And so this tells us that certainly it tells us that d is strictly less than square root n. We could probably get an even better bound for that. So it's only, and the reason why the square root n is interesting is that the divisors of n come in pairs. N come in pairs. A times b, where a is at most root n and b is at least root n. So it's got a larger divisor and a smaller divisor. And the consequence of this is that half of the divisors of n are below root n. Or at most half, because if n is a square, then the number of divisors is odd, so we have to be a bit more careful about how we phrase this. But for now, I'm just ideating. And so I think that actually already proves that only half of the divisors can be special, because any special divisor is one of the half of the divisors that are smaller than root n. Yeah. Cool. And so now we want to find all positive integers n where exactly half of the divisors are special. So exactly half of the divisors are special. Half of the divisors are special precisely when 1, 2, 3, 4 up to the floor of root n are divisors of n. And that's probably too many divisors to be half of the divisors of n. Yeah, so this implies that the number of divisors is something like 2 times the square root of n, but actually the number of divisors is something like usually a lot smaller than that. I don't know exactly what I want to claim the number of divisors is, but it's something involving logs, not square roots. I don't know if that's the best approach, but maybe we can try that. So if n is p1 to the a1, p2 to the a2 to pk to the ak is the prime factorization. Then the number of divisors, which has to be 2 times the floor of root n, is the number of divisors. Oh, no, I'm lying. Yeah, no, this is right, because we know that for every number below floor of root, below root n, if d is below root n, then d plus 1, then it's a special divisor. If d is a divisor below root n, then it's a special divisor. So d plus 1 is also a divisor, yes. So 1's a divisor and it's special, so 2 is a divisor. 2 is a divisor and it's special, so 2 plus 1 is 3 is a divisor. 3 is a divisor and it's special, so 3 plus 1 is 4 is a divisor, and so on. In fact, this also tells us that the ceiling of root n is a divisor. Is the first non-special divisor. And it pairs up with that one. Yeah, I still don't see a quick way to do this, so let's go with counting the number of divisors. And this is equal to a1 plus 1, a2 plus 1, ak plus 1. And so the thing is that I'm thinking is that this is very small compared to even the square root of that. So let's take this divided by the square root of n. So we have a1 plus 1 over P1 to the A1 over 2 times A2 plus 1 P2 to the A like this. And I'm splitting it apart like this because then I can deal with each prime power separately. So this is number divisors over square root of n, which is 2 floor root n over root n, which is strictly less than, I don't know if that's good enough because these are all, none of these are going to be, that's actually fine. It's that this is too large. So we want to, I don't think this is the right approach. This is too large to possibly be the number of divisors of n. So we actually want to bound this below. So yeah, this is, the reason this is not going to work is because it's greater than or equal to 2 times square root of n minus 2. Yeah, and that's too large to be the number of divisors of n. So let's do the dividing by p to the 2k thing that we had. Yeah. So the question is, how typically does x plus 1 over p to the x behave? And that is tiny. You have lots of prime, that gets smaller. Yeah. X over 2. Yes, let's do that. So if we take this and do what we did earlier, we know that a1 plus 1 over p1 to the a1 over 2. Let's make this ai, pi. So the product of these things is the number of divisors divided by square root n. And so that's greater than or equal to 2 minus 2 over root n. Whereas on the other hand, we know that ai plus 1 over pi to the ai over 2 is less than or equal to ai plus 1 over 2 to the ai over 2. And this is so if all of the primes are only to the first power, then this is not going to, and this might be okay. This is getting finicky. Problem is that this can be bigger than 1. I can show that 2 or 3 must be a prime divisor. There must be a better way to do this. This is going to work if I carry on with it, but it just doesn't feel pretty. Okay, fine. Let's take this thing. If pi is greater than or equal to 5, then x plus 1 over p to the x over 2 is less than or equal to x plus 1 over 5 to the x over 2, and this thing seems to be decreasing, so this is less than or equal to 1 plus 1 over 5 to the 1 over 2, which is strictly less than 1. How can I justify that this is decreasing? I can't. Or let's show that x plus 2 over 5 to the x plus 1 over 2 is less than or equal to x plus 1 over 5 to the x over 2. Let's cross multiply. This is equivalent to x plus 2 over x plus 1 is less than or equal to 5 to the less than or equal to root 5. And this thing is clearly decreasing, so if it's true at 1, it's true forevermore, so this is, yeah, this is decreasing. So at least all the primes in the prime factorization that are 5 or more, this term in the product is making this smaller and smaller and smaller. And also what we see then is that if 2 or 3 is not a prime factor, then this product is strictly less than 1, but it needs to be bigger than 2, or something just less than 2. So 2 minus, if 2 minus 2 over root 5 maybe. It has to be bigger than, at least if n is bigger than 5 say, then this has to be bigger than 2. If n is bigger than 4 even, then this is greater than or equal to 1. So this is greater than or equal to 1 if n is greater than or equal to 4. Which is certainly the case if all the prime factors are 5 or more. So we know that 2 or 3 must be a prime factor. What is, okay. And we can probably limit, one of these has to have a fairly small exponent as well, because when this gets large, then this is again, now even with 2 as the prime, we know that this is going to be rapidly get smaller than 1. So 2 plus 1 is 3 over root 2 is still, no, 3 over 2 is still bigger than 1. So this is 3, then this becomes 4 over 2 root 2. 2 over root 2 is still bigger than 1. If this is 4, 4 plus 1 over 4 is still bigger than 1. 5 plus 1 is 6 over 4 root 2 is smaller than 1. So I think either the exponent of the 2 must be at most 6, or the exponent of the 3 must be at, there must be a better way to do this. Maybe the fact that this is a divisor of n is already, yeah, of course, okay, that is already limiting, because we know that floor root n plus 1 is a divisor. Floor root n plus 1 is ceiling root n when n is not a square. And so these are the two that pair up. So actually that must be equal to n. This is greater than or equal to... let's see, if n is... yeah, we know that n must be s times s plus... must be of that form. We know that s minus 1 is also a factor of the... yeah, so this is floor square root n. And this is ceiling square root n. Okay, and we know that s minus 1 was a divisor of n. So we know that s minus 1 divides s plus 1, because this is n. And we know that everything smaller than root n is a divisor of n. And so this implies, because s minus 1 and s are relatively prime, this implies that s minus 1 divides s plus 1, which implies that s minus 1 divides s plus 1 minus s minus 1, which is 2. And so s minus 1 equals 1 or 2. It can't be negative because s is at least 1. And so this implies s is 2 or 3. And that implies that n is 6 or 12. And then the question is, we can check. So 6, the divisors of 6 are 1, 2, 3, and 6. And here we see that exactly half of the divisors are special. They are 1 because 1 plus 1 is a divisor, and 2 because 2 plus 1 is a divisor, but 3 and 6 are not special. And the other option was divisors of 12. One, 2, 3, 4, 6, and 12. And then here the special divisors are 1, 2, and 3, but 4, 6, and 12 are not. And so, yeah, the numbers where exactly half of the divisors are special are 6 and 12. And I think this is going to be where I stop for the evening. But I'm going to leave the stream running so that it can catch up, because otherwise, because of the lag, it's just going to cut off the stream here, and that would not be ideal. But yeah, thanks for watching, and I'll be back on Sunday.